function. Because, gosh, this is a pain in the butt. God. I got to type now, I think. Okay. The inverse is not a function because when I went to solve for the inverse, I got two functions and not one. There's only a function if there's one function when I solve for the inverse. Like the first problem, there was only one. Y equals x plus 10 over 3. Okay. So that one was a function. The second one is not the inverse is not a function because it turns into two functions, plus and minus. That's the abbreviation for inverse. Yeah. So you'll see it written, just as y equals, or you'll see it written as f with a -1 up there. No, they just put it on the function notation. They don't put it on the y. Okay, so next we need to graph these. Now I have to graph with my finger. Please start working again. It's the pen flicks aren't working. Okay. All right. It works up top. Works up here. You really? All right. All right. So let's graph. Okay. Let's graph. Shh. Let's graph the function. The function is y equals x squared minus 2. If I'm going to graph the function y equals x squared minus 2, let me just get 3 points, one of them being the vertex. So, sorry. So my vertex at negative b over 2a is, what's b for this one? 0. So my vertex is going to happen at 0 comma something. So in my little XY chart, I'd like 0 there. I'd like a number less than 0 and a number greater than 0. When x is 0, x squared, I'm sorry, when x is -1, x squared minus 2 is -1. When x is 0, x squared minus 2 is -2. And when x is 1, x squared minus 2 is -1 again. Let me put down those 3 points if I possibly can. Come on. Dot. -1, -1. And, okay, those dots are very light, but they're there. Yep. So in y equals x squared minus 2, a is 1, b is 0, and c is -2. Okay. Yes? So why is a 1? Because there's a coefficient of 1 in front of the x squared. And b is 0 because there is no linear term. It's 0x. C is -2. Okay? Now I'm going to put the inverse on the same graph. So I'm going to try writing in red here. So the inverse function is y is -1. I'm sorry, x is -1, -2, and -1. I just copied down the y column. And the y's are -1, 0, and 1. So let me graph those. -1, -1. Can't see it, but it's right there. -2, 0, right there. And -1, +1. Where did I get those numbers? They are the three numbers for the y in the function become the 3 numbers for the x in the inverse of the function. Just copied one column down to the other. Okay, which other part? Okay. Okay. So to graph the inverse, I inverse the xy coordinates. -1, -1, -2, 0, -1, 1. And there you go. There's the inverse graph. Pardon me? Okay. It's easiest to graph inverses if you just inverse your table, your XY table. Yeah. Mm-hmm. No, I just took this table in black, and the inputs for this table in black are -1, 0, and 1. I made those the outputs on the table in red. To get the points in black, I used the vertex in the middle and then chose one number less than the 0 and one number greater than the 0, and then to get to y's, I put those numbers into x squared minus 2 to calculate the y's. Okay, cool. All right. So and you can graph these as a reflection across the y equals x line. And if you're pretty good at spatial things, you probably can do that without having to switch the tables. But sometimes you need to switch the tables. Yes, ma'am. Okay. All right. Are we good? I hope we're good because it isn't working.